All right, welcome to the Math 3 Semester 1 final review. Let's get going. So number 1, it says, write the respective inverse function for each. All right, so let's start with 1a. f of x equals 3x plus 7. So recall that inverse functions, we always have the same 3 steps. So first we're going to rewrite it using y. 2, if there are any like half powers or third powers, we'll rewrite those, but in this one there aren't. So then we'll switch x with y and then solve for y. Now, when we solve for y, just a reminder that if we have a quadratic, we would solve differently than if we have a linear. So we have a linear function here. So we're going to rewrite it using y equals 3x plus 7. And then we would switch x with y. And then solve for y. So to solve for y, we would subtract 7 from each side. And then we would divide both sides by 3. And we get y equals x minus 7 all over 3. Or they may split this and write it as y equals x over 3 minus 7 over 3. Or they could even write it as y equals 1/3 x minus 7 over 3. All right, oh, and the last step is to use F inverse notation. Okay, so we would rewrite this with F inverse x. All right. Number 1b, f of x equals 12x minus 6. So again, we'll rewrite it with y. Switch x with y and solve for y. So we'd add 6 and then divide by 12. And then we want to make sure we have all 3 cases. Y equals x plus 6 over 12, that could be the answer. Or it might be y equals x over 12 plus 6 over 12, but 6 over 12 is 1/2. Or it might be y equals 1/12 x plus 1/2. Again, just a reminder, 6 over 12, if we divide both the top and bottom by 6, we get 1 over 2. All right, and for C, I'll do C right over here. F of x equals 12x plus 10. We'll rewrite using y. Switch x with y. And then start solving. We get divide by 12. Y equals, we have x over 12 minus, all right, 10 over 12, divide both by 2, that's 5 over 6. Or we could have all in one fraction, x minus 10 all over 12. Or the third way would be 1/12 x minus 5 over 6. All right, so each of those is equivalent. Make sure that you could recognize any of those. Okay, next. Solve algebraically for all values of x if the square root of 11 minus x plus x equals 5. So remember that when we are solving square roots, first we need to isolate the radical. And then second is to square both sides. And then finally is to solve for the variable. In this case, it's x. All right, so we have square root 11 minus x plus x equals 5. So to isolate the radical, I would move the x over. Whoops. All right, this is where I saw people struggling right here on this step. And so it's the square both sides part. Squaring this side, people were fine. It was squaring this side. Remember, we're squaring a binomial. And so that's 5 minus x times 5 minus x. And so when we have to FOIL this out. It's going to be x times x, which is x squared. Remember, a negative times a negative is still positive. And then negative 5x, and then 25. Okay, at this point, here's another sticking point, right? So at this point, we have a quadratic. And so to solve for x, you need to set equal to 0, and then either factor or use the quadratic formula. One of the two, right? So we either need to factor or use the quadratic formula. So we need to set it equal to 0 first. So I'm going to add x to each side and subtract 11. I'm going to go ahead and combine like terms too, but I'm adding x and I'm subtracting 11. So this gives me 0 equals x squared. That would be negative 10x plus 1x, which is negative 9x. And then 25 minus 11 is 14. Okay, so now we're going to see if it factors. So if it factors, we need something that multiplies to 9 and adds to multiplies to 14 and adds to negative 9, which would be negative 7 and negative 2. Remember, no leading coefficient, so we don't need to factor by grouping. So this is going to be x minus 7 and x minus 2. All right, so our two possible solutions are x equals 7 and x equals 2. Now, we must check, and the reason is when we square both sides, so in this step right here, when we squared both sides, we could have introduced an extraneous solution. In fact, I'm going to look at the graph of the next one. This is a square root function. Even this one doesn't cross the x-axis at all. This one has no real solution, but a square root function can only cross through the x-axis at most one time. So a square root function either has one or no solutions, real solutions. So we have to check both of these because one of them is extraneous. So we're going to check both. 11 minus 7 plus 7 equals 5. All right, the square root of, that would be the square root of 4 plus 7 equals 5. That's 2 plus 7 equals 5. No, it does not. This is extraneous, but we need to check this one. It's possible that neither work. So we're going to check the other one. 11 minus 2 plus 2 equals 5. 11 minus 2, that's 9 plus 2 equals 5. Square root of 9 is 3 plus 2 equals 5. That is true. Check. That is a valid solution. So again, this one's extraneous, and this one is a valid solution. Number 3. It says the function, a function is graphed on the coordinate plane. Write the equation for the function. All right, so first you have to recognize that this is a square root function. And so the parent is y equals square root x. So what I'm going to do is I'm going to graph the parent, and then I'm going to compare this function to the parent function. So I'm going to graph the parent, and then I'll compare. And remember that we're going to be writing something like y equals a square root x minus h, and then plus k. All right, so to graph the parent, if you don't remember the parent function for a square root, you can always make a quick table of values. I can't pick negative numbers because I can't pick negative numbers and put them under the radical. And so I will pick only positive numbers like 0, 1. I can pick 2, 3. These are not perfect squares though. I'd rather put perfect squares like 4 and 9. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So I'm going to graph my parent, which is 0, 0, 1, 1, 4, 2, and then 9, 3. And so my parent function is right here. Now, what I notice is I'm gonna make sure that I'm gonna try to find a first, right? So I'm gonna make sure that I go up 1 over 1, and then I would go up 2 over 4. So let's check that. So if I start here, I go up 1 over 1, yes. I go up 2 over 4, that is true. Okay, so a has not been changed, so a is still 1. All right, h and k. I do notice that I've shifted to the right. I've shifted to the right 3 units, so h is 3. And I've shifted up. I've shifted up 2 units, so k is 2. And we're going to substitute that into our equation, right? Y equals, so my function will be y equals, a is 1, so no need to write it, x minus h is 3, and then plus k is 2. That is my function. Okay, moving on to number 4. What does the term one-to-one mean? Okay, so one-to-one means the y's don't repeat. Also, it will pass the horizontal line test. Passes horizontal line test. Okay, so now knowing that one-to-one means that, then the next question asks, which of the following cube roots is not one-to-one? All right, well, we need to know what a cube root function looks like so that we can decide which of those would not be one-to-one. Again, I'll look at my parent, cube root x, build a quick table of values. Now remember, with a cube root, you can pick negatives. I'm going to pick perfect cubes. 8 is a cube, 1 is a cube, 0, 1, and 8. And y equals cube root x. The cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of positive 8 is 2. So your parent function is at negative 8, negative 2, negative 1, 0, 0, 1, 1, and 8, 2. So your parent function looks something like this. And it is a one-to-one function, right? It'll pass the horizontal line test, and also the y values do not repeat. Now, with the transformation, we would have a x minus h and then plus k. Now they can write a in a couple different ways. They can write a out front, or if it was a fraction, they could write something like cube root x minus h plus k and then all over a right here. Either of those would be valid. Regardless, scaling means stretching, right? Reflecting across like this coming up here and this going down there, shifting left or right or up or down, none of those will change the fact that this is a one-to-one function. So all are still one-to-one. What we cannot have is something wonky going on. So on the first one, all we have is a shift. Right? A shift will be fine. On the second one, we have something odd going on right here with this squared. We'll talk about that more in a minute. On this one, it's a shift, right, up and left, but still it's just a shift. And this one is a shift in a scale. Again, this is the case where they put the 3 in the denominator, meaning they're scaling by a third. But what's weird about this one is that we have an x squared. I want you to think about what would happen if we're squaring our x values. So if I square my x values, for example, and I pick negative 1, 0, and 1, I would have 1, 0, and then 1 again. Do you notice my y's would repeat? So because of the square, b will not be one-to-one. I'm going to stop this video here and pick it up on the next video.